Assalamualaikum warahmatullahi ta'ala wabarakatuh. Okay, today we need to understand electric flux. So the electric flux. Okay, so first thing I give you the definition of the electric flux. Okay, so definition of the electric flux: the rate of flow of the electric field then the symbol of electric field is E, through a given virtual surface area. Okay, so the definition of the electric flux: the rate of flow of the electric field through a given virtual surface A. Okay, so we continue. So the electric flux is proportional to the number of electric field lines through a virtual surface. Okay, so this is a simple notes about the electric flux. So we continue. So symbol of electric flux. So symbol is psi. Then what is the unit of electric flux? Actually is Weber. So this one, the unit of electric flux. And then we call as a Weber. Okay, so now we continue. So before that, I draw the lines of electric fields. Here, we start from here. This one is the line of electric field. Then I draw another lines. Okay, now I draw the lines of the electric field. So this one is the direction of the electric fields, and Newton per Coulomb is the unit of the electric field. So this one we call as the electric field lines, and then the from direction from here to here. Okay, so we continue. So I divide for the 1, 2, 3 segment. So one, here is a 2, 3, Okay, so we have the 3 segment here. So we continue. So I draw here. So I draw the virtual surface. So the first case is this one. So the first virtual surface, and then the vector of the area is perpendicular to the surface. So here is the vector of the surface, and then we go for the second case. Now is here. So the surface is this one. Here is the vector of the surface. Then we make it angle theta with the electric field. And then the last one is here. So I draw the virtual surface. And then the vector of A, vector of the surface is here. So just to explain here, this one is the virtual surface. So the virtual surface, okay. So this virtual surface, so the vector of the virtual surface must be 90 degrees with the surface. That's why the direction of the A is here, because the 90 degree with the virtual surface. And then for this surface, the vector of A is up here. Direction is here. Why? Because they need to be 90 degrees with the virtual surface. Okay, then for this one is the virtual surface. So the direction of the vector A is here. They must be 90 degrees with the virtual surface. Okay. So we continue. So we study the first case here. So the question is, what is the angle? So what is the angle? The angle between what is the angle theta between vector A and the vector E, electric field? So from the diagram, so the theta then is equal to 0 degree. So because this one is the vector A, and then here is the direction of the vector E. So the angle between the A and the vector E is 0 degree. Then we continue. So we can calculate the electric flux by using this equation. The magnitude of E times the magnitude of A cos theta. So we continue. Cos, and then the angle theta is 0 degree. Therefore, we can calculate the electric flux. The magnitude of E times the magnitude of A. Now for the first case. So we continue for the second case here. So what is the angle? So the angle theta between vector A and vector E. So then we can find from the diagram. So the diagram show the theta is equals to the theta degree in this case. See? So the angle between the vector A and the E is theta. Then we continue. So we can calculate the psi. So the magnitude of E times the magnitude of A cos theta. Then we continue A, so the cos, then the theta is a theta degree. Then we can calculate the electric flux by apply this equation. So we continue. So what is, so the angle, what is the angle theta? So between the vector A and the vector E. Then from the diagram, so the theta is equals to 90 degree. See, here is a vector A, here is a vector E, so the angle here is supposed to be 90 degree. Then we can calculate the electric flux. Psi is equals to the magnitude of E times the magnitude of A cos theta. So continue E cos theta is a 90 degree, so therefore is equals to the magnitude of E times magnitude of A. Cos theta is, cos 90 degree is 0, so therefore the psi is equal to 0 Weber. Okay, so this one is how we can calculate the electric flux based on the situation here. So the first one is here, the first diagram show that the A is parallel with the E. So the second case here, we have the angle between vector A and vector E. And then for the last case, actually the vector A is 90 degree with the E, because the cos is 90 degree is equal to 0. And then for this case, we don't have the electric flux. Okay. Hope you understand the electric flux. For that, thank you.